Hey guys, Mrs. Sands here. So sorry I can't be here today, but we are starting Unit 3, which is called Systems of Equations. So if you could just copy this objective onto the lines in Lesson 1, you'll see that today we're actually still graphing. So what we did in our last unit, of course you need to recall that information. We still will be graphing using the slope and y-intercept. It's just that we're definitely always going to graph more than one line on a set of axes. And we're going to learn what the solution to that system is. When we graph more than one line, that's when we call it a system of equations. So get this objective written down, start your do now. Of course, I'll go over the do now with you. If at any time the video is going too fast, please pause, catch up, and then continue. So this do now is asking us to graph the following equations on a set of axes below using the slope-intercept method. So one thing that stands out to me is that they're both already in y equals mx plus b form. Remember, if a linear equation is not in this form, you have to use inverse operations to get it in this form. So when it says y equals, we're already happy. It's already set up nicely for us. Remember, the slope is the coefficient of x, so the slope is 2. We like to write it as 2 over 1. And the y-intercept is -3. Remember, we start at our y-intercept, and when the slope is positive, we go up and right. So let's graph this first line. I'll start at -3. And I'll go up to right 1. Please go to the edges of the graph. You shouldn't be copying me plotting points. You should start at the y-intercept and then count yourself up to right 1. Of course, go in the other direction as well. The line should go to the edges of the graph paper. You need to put arrows at the ends. You need to label your line. And now we're going to do the other equation. I'm going to pick a different color. So the slope is -3 over 2, and the y-intercept is 4. Again, this was already in y equals mx plus b form. The m is always the coefficient of x. The b is always the number being added on. So let's start at 4. And now that our slope is negative, let's go down 3 and right 1. Remember, we always go to the right. Positive means goes up, negative means go down, but we always go over to the right. Go to the edges of the graph paper and go in both directions, please. Make sure you put arrows and label your line. And now I have done what the do now asked me to do. I had to graph each of the equations on the same set of axes. Now we're going to talk about this as a system. So if we look at the next page, it asks us to state the point where the two lines intersect. So I'm going to go circle it for a second on my graph. The two lines intersect right here, which is the point 2, comma 1. So let's focus on what this really means now. So a system of linear equations is when we find an ordered pair that is a solution to more than one linear equation. And one way to solve a system is by graphing. So when we solve a system graphically, the solution is where the lines intersect. This is an important statement. I like to say that the solution is the point of intersection. The solution is the point of intersection. So the solution to the system that we did in our do now was 2, comma 1. It's a point. It's an x value and a y value. Both equations share this point. A solution is the point that they share. So we're going to check it in each equation. So remember, when we do a check, we plug the x value in place of x, we plug the y value in place of y, and it should work out. So the first equation was y equals 2x minus 3. So let's do 1 equals 2 times 2 minus 3 and make sure that this actually works. It does. So it's a solution to the first line that we drew. What about the second line? Is that point 2, 1 a solution to the second line? So substitute in 2 for x and 1 for y. And it works in the second one as well. So when you find the point of intersection, the check will work in both equations. If the check doesn't work in both equations, it means you probably made a graphing error and you found the wrong point. So when we graph correctly and we find the point of intersection, that point of intersection is the solution. If it is the solution, it will check in both equations. So let's do some practice now. Example 1 is practicing our horizontal and vertical lines. I would hope that you kind of have this set in memory now. Whenever it's y equals some number, it's always a horizontal line. And whenever it's x equals some number, it's always a vertical line. So I go to y, I go to -2, and I draw a horizontal line. The y-axis, -2, horizontal line. Let's label it y equals -2. On the next line, I go to the x-axis. I go to 3, and I draw a vertical line. Here's the x-axis. Here's 3. Draw a vertical line. Sorry, my line is not going very straight. Make sure you're labeling your lines. If I needed to state the point of intersection, which I do, I find where they cross and label it. It is the point 3, -2. This is called the solution. Label it, the solution. The solution is 3, -2. Let's do 2 checks for this. We're going to check in the equation y equals -2, and we're going to check in the equation x equals 3. What is it that we're checking? We're checking the point of intersection, 3, -2. This is an x and this is a y. So in place of y, I'll put a -2. There is no x in this equation, so there is no x to plug in. -2 equals -2, it checks. When I do the second check, I'm still checking the same point, 3, -2. This is my x, this is my y. In place of x, I put the 3. There is no y to substitute in. I can see 3 equals 3. So my solution is 3, negative 2, and it checks in both equations. Remember, you can hit pause if I'm going too fast. Example 2. So something I notice about example 2 is that this first equation needs to be fixed. I'm putting it in quotes. What do I mean by fix it? I need it in y equals form. So I'm going to come over here and I'm going to get it into y equal to form. I need to keep the y there. I have to get rid of the plus x. So I'll subtract x from both sides. Now I have y equals 2 minus x. Or I can change the order and say y equals negative x plus 2. I don't care which way you write it, but the y has to be by itself. And you have to recognize that the slope is negative 1 over 1, and the y-intercept is 2. So let's graph this first line. Let's start at 2, and let's go down 1 and right 1. I like to label it with the original equation, y plus x equals 2. What I notice about the second equation is that it's good. It's already in y equals form. So if y equals negative x minus 2, the slope is negative 1, and the y-intercept's negative 2. I'm going to start at negative 2. I'm going to make my slope look like a fraction, and I'll go down 1 and right 1. Do you notice that both lines went down 1, right 1? They just started in a different spot. So if lines have the same slope but a different y-intercept, they're going to be parallel. That's always true. If lines have the same slope and a different y-intercept, the lines will be parallel. So, what's the solution? Remember, the solution is supposed to be the point of intersection. There is no point of intersection. This has no solution. No solution since the lines don't share a point, or since they don't intersect. Parallel lines never have a point in common. Parallel lines never have a solution. So sometimes we can graph two lines and there is no solution since the lines are parallel. So parallel lines don't meet. Parallel lines have the same slope. So if you're ever given a question that asks you to solve and the lines turn out to be parallel, your answer is this: no solution. No solution. Okay? Let's move on. Example 3. Again, notice this first one. It's not in y equals 2 form. We need to fix this. The second one, It is in y equal to form. This one's good. So I want you to be able to look and recognize that quickly. Let's do the good one first. The slope is -2. I could put a 1 underneath it. The y-intercept is 4. So let's go start at 4, and let's go down 2 and right 1. Remember, you all have access to this video when you go home. So if for some reason you missed something in class, you can go back and look at it when you're at home. Fast forward to the part that you missed or need help with. I want you all to start off this third unit well. Start off saying, I'm going to do everything I need to do to be successful. So let's fix this one. Remember, I'm trying to get this y by itself. So don't even touch the coefficient yet. Don't touch the 2. Save that for last. Let's get rid of the plus 4x by subtracting 4x from both sides. So I'm left with 2y equals, I can write 8 minus 4x, or I can write -4x plus 8. Right? I just used the commutative property. I just wrote the second thing first, and that's allowed. I have to get rid of this 2 in front of the y. Remember, this 2 divides on both sides. This 2 divides into both pieces of your numerator. So I'm left with y equals -4 divided by 2 is -2, and there's an x next to it. And 8 divided by 2 is 4. So now I see that my slope is -2/1, and my y-intercept is 4. So I have to start at 4, and I have to go down 2 and right 1. So let's go start at 4. Okay, it has the same y-intercept. Let's go down 2 and right 1. Doesn't each point land on a point that was already there? Interesting. If I connected, it's the same line, isn't it? So it was 2 equations. Therefore, it is 2 lines. But these 2 lines land on top of each other. So it's 2 lines that land on top of each other. So I'm going to label this second line, the 2y plus 4x equals 8. Remember, the solution is the point that they share. Don't you agree they share all the points? These 2 lines share every point. So I can't really name a solution. There's so many of them. Really, what we like to say is if the lines land right on top of each other, we say that the lines coincide. If the lines coincide, that means that there's an infinite number of solutions. This system has an infinite number of solutions. And that's because they share every point. The solution is the point they share. This one shares every point. So there's an infinite number of solutions. So let's sum up now. So when you graph 2 linear equations on the same set of axes, what type of solutions can there be? So our do now showed that you can have one solution. Our example number 1 showed one solution, right? So we can have one point of intersection. So there can be one solution. The second kind of solution is what example 2 showed. Parallel lines. What did we say about the solution? Oh, we said that there's no solution. And that's because they didn't share any points. And then what's the third type of solution? Well, it's right here, example 3. When the lines coincide, when the lines land on top of each other, we say that there's an infinite number of solutions. Let's actually draw a small little diagram to represent what these solutions look like. If there's one solution, I'm going to have two lines that meet at a certain point, and that point is the solution. If there's no solution, then I'm going to have parallel lines. They never meet, therefore there's no solution. If there's an infinite number of solutions, I'm going to have one line land on top of another line. Now I can pick two colors to try and draw two lines, one on top of the other. You just need to remember that these lines are on top of each other in your notes. So I'm going to ask you to do these two practice problems on your own, and then check on my Google Classroom for the notes that I have left so that you can check and make sure that you have these two problems done correctly. And then when you're done with these two problems and they're done correctly, you can then start your homework, which is this problem set. So for homework, you can see that you don't have many questions. Total of 7 questions. They're all about graphing, and you're stating the solution. Remember, the solution is the point of intersection. So find the point of intersection. If there's one, then we call it a unique solution. That's what this is down here. What type of solution? It could be unique, which means one solution. Or if they're parallel lines, there's no solution. Or if the lines coincide, there's an infinite number of solutions. So for each one, that's what you're doing. You're finding the point of the intersection. So enjoy the rest of your day, and I'll see you soon.